Alright, awesome. So my name is George Garcia. I'm the support specialist here at Autodesk EAGLE. So this is going to be Top Gun manual routing, and with me we have Ed.
My name is Edwin Robledo. I'm part of the Global Support Specialist here at Autodesk EAGLE as well. And thank you for joining our webinar this evening. The Autodesk EAGLE router has many functions such as new routing engine, obstacle avoidance. In this webinar, we're going to be basically concentrating on manual routing. And Jorge is an expert on this one. So Jorge, can you just give us a demonstration about it, please?
Alright, so let's go live. Can everyone confirm that they can see my screen? If anything, just message Ed if you can't. So everything we're going to go over today, we can go over using the Hexapod example board. So if you guys have EAGLE installed, you can go through it with me. First thing I'm going to do is just rip everything up. And the easiest way to do that is type the word rip up, semicolon, hit enter. It's going to ask you if you want to rip everything up. You're going to say yes, and all of the routing is gone. Okay, everything reverts back to AirWire mode, so it's really easy to, it's going to be really obvious what I'm routing and when I'm routing it. So the first thing we want to go over is Drc and Net Classes, since that sets the basis for the manual routing and the various modes that we're going to be looking at today. So if we go into the DRC, we have the File tab. We're going to focus only on a few tabs, the ones specifically related to routing. But I just want to touch on the File tab because you can set up design rules for different manufacturers, save them, and then load them at will. So if you have a design and you're getting it made with one manufacturer and you find out they're going to take too long, you can always go to one of your other manufacturers. If you just adjust the rules, run a check, make sure everything is still okay, and that way you have confidence that even though you're going to another manufacturer, the board design will still be okay. So we're going to talk on layers very briefly. By default, EAGLE always goes to 2 layers, layers 1 and 16. Any additional layers that we may be routing to have to be set up here first. So the easiest configuration for something like a 4-layer board would be 1 times 2 times 15 times 16. Okay. The plus and the asterisk, you'll notice that in the manual we usually mention plus and the asterisk. Those indicate core versus pre-preg. Currently that information doesn't make it into the manufacturing data, so you don't have to be too concerned about it. For the basic example, I've just put everything as a core. In real life, what you would see is that the center of the board would be a core. In other words, it has a copper layer on both sides. And then everything out from that would usually be prepreg, which means it only has copper on one side. And that way you have uniform copper thickness on each of the layers. But again, none of this information makes it to the Gerber, so you don't have to stress too much about it initially. Same thing with the information here of the copper thicknesses in isolation. If we're making blind and buried vias, again, I'm just going to briefly touch on it. You do want to set them up before you do your routing task. Okay, because if you set up blind vias, for example, and you transition from layer 1 to 2, EAGLE will automatically put in a blind via. So if we do something like this, okay, you'll notice that you have your through-hole vias for all layers, and you have the blind via. So while routing, if you transition from the top to layer 2, instead of using a through-hole via, EAGLE will automatically use a blind via. So it should become pretty clear now that if you route the whole board and then do this, now you're going to have difficulty having to go back and rework a lot of your traces to make sure that you use a blind and buried vias. So very important to set up your layer stack up before you start the routing task. Okay, this is how to set blind vias. Here's the example. The way it works is whatever number's in the front goes to the top layer. Likewise, whatever number's on the end of the string is from that layer number to the bottom. You always want to enter layers from the outside surfaces towards the middle. Okay, so here you saw 1, 2, 15, and 16. You do not want to do 1, 2, 3, 4. Okay, always outside surfaces towards the center. Especially in size limited versions, this becomes critical because you're only allotted a specific 4 layers in the standard version, which are layers 1, 2, 15 and 16. Okay. For the example in this case, we're going to just leave it at a basic 4-layer board for the routing, just so that we have the ability to transition between a few layers and show off some of the other routing features. Clearances are important. Generally, you're going to set them up uniformly. There are a few rare occasions where you maybe have a specific clearance that's different than the rest, but in general, the board house just gives you a minimum clearance, and that's what you would set up here. Okay, the default DRC is very conservative. Most board houses nowadays can do 6 mils without any additional charge. But again, we want to be extra safe in EAGLE, so we've set up this conservative DRC by default. 8 mils. If you can pass 8 mils, you can almost, toner transfer a board and be pretty certain that it will work. The distance tab, I just want to make a key point here about copper/dimension. What this parameter controls is usually how close copper can get to the edge of the board or any cutouts within the board geometry. Okay? 40 mils is extremely conservative. You can usually half it and be okay. So this is going to dictate how close copper can be to the edge of the board. Drill hole is just a separation between two drills. Okay, the minimum separation. Again, the board house will usually specify it. The last one we're going to talk about today is the sizes. Okay, under sizes, you're defining a minimum width for the whole board, a minimum drill size, and then to a lesser extent, micro via and blind via ratio. We're not going to discuss these too much. There's only one thing I want to make clear here, is as long as the minimum micro via is larger than the minimum drill, then micro vias are disabled. Okay, so by default, EAGLE disables the micro vias by making this value larger than the minimum drill. Okay, 24 mils for a minimum drill is again extremely conservative, as is the 10 mil minimum width. Usually, most board houses can handle a 16 to 18 mil minimum drill, and for minimum width, 6 is pretty common. But again, for conservative reasons, we ship this by default. So I'm just going to say apply. I'm going to say cancel here to keep the settings. Now, you have the global DRC, which affects the whole board. But for a routing task, we also want to keep in mind the net classes. This is the other half of controlling your routing. So we're going to go into Edit, then Net Classes. And you'll notice that we have two net classes here. We have Default and we have Supply. Now, one thing to keep in mind with the net classes is that they are always in competition with the DRC. Okay, the net classes and the DRC always compete. The larger of the two will win. So if you guys remember in the DRC, we had set our minimum width to be 10 mils. Here, the default net class has a width of 16 mils. 16 mils is larger than 10. So every trace that's on the default net class is going to be 16 mils instead of the 10 mils that the DRC specifies. As a general rule, as a general recommendation, you want the default net class to be all zeros. When you do this, you're basically allowing the default net class to be subject to the DRC. For anything outside of the DRC or any larger requirements that you may have for clearances or for width, then you want to create additional net classes, which is what we see here, the supply net class. This one has an additional width compared to our default, because anything that's on the supply net class requires 45 mils, which is obviously greater than 10, so this will win. So you want to keep this in mind when setting it up. Because the default is all zeros, all of the clearance values we set up, all of the drill values we set up, all of the width values that we set up in the DRC manage the default net class. Anything outside of that, you have to define additional net classes for. Okay? So keep that in mind. Net classes and DRC are always competing with each other. So for the supply, let me see if I can put in a little bit of a larger clearance. Let's say 15 mils, just to make it obvious later when we start routing. So I'll say OK. And we've finished our net classes. So let's start routing. If any of you are coming from version 7 or prior of EAGLE, you probably will have observed that the routing behavior in EAGLE now is very different to what you're used to. Okay, so we're going to cover some of the common use cases and caveats on that. So let's click on the route command. And for now, I'm going to set everything up to be in basically the way it used to be in the old versions of EAGLE. So we're going to put it in ignore obstacle mode. And I'm going to leave the loops alone. I'm going to take off loop removal. Okay, by setting it this way, the behavior of the route command is basically similar to what you had in version 7 in regards to not having any of the new features. By doing this, I've disabled the new features in the version 7 and the Autodesk EAGLE routing just to illustrate the differences in its behavior. So we have route active. And the first thing we're going to do is we're just going to route one of these nets over here. Let's route this one. Okay, so you can see I can run over everything. The first clear difference that we're going to run into is when we try to place a via. In older versions of EAGLE, you would route up to where you wanted to place a via. You would left click, click the center mouse button, select what layer you want to transition to, and then keep routing. As soon as you finish the segment, EAGLE would drop the via at that location. Things are very different now. So I'm going to pick a circular via. And if you notice, you can still use the middle mouse button, but I like to use the new spacebar shortcut. So if I hit spacebar, you're going to notice that now the via immediately shows up on the end of the trace. I can place it anywhere I want. Now if you look at the bottom here, it's going to tell you what layer you're transitioning to. So if you guys take a look down here, watch what happens as I keep hitting my spacebar. Okay, so it's switching between the two layers. So I'll left click and I'll keep going now. I'm on top. And I can do the same thing again. You'll notice that by pre-placing the via, you have a good idea of where it's going to end up and you have full control without having to change it after the fact. So again, I just switch and I can keep going. Now let's say I made a mistake in the route. If I start hitting the backspace key, I can start undoing segments all the way back to the first one. Okay, and then I can choose to go in another direction. So definitely one of the big improvements of the routing engine is this ability to very easily undo your last segment. In older versions of EAGLE, you would just have to finish the segment and then go and rip up and rework whatever you needed to redo. Okay. Let me check something. Okay, good. So let's go ahead now and let me go ahead and rip that up. And I want to show you guys something else. Let's say I click here. If I start left clicking, all I get is the via. But what if I didn't want to route on the bottom? What if I wanted to initially start my route on the top? What you're going to do in that case is you're going to hold Shift and then middle click on your mouse. If you do that, EAGLE's going to ask you, okay, what layer do we want to route to? Select layer 2, let's say. And I can route from that one. Okay, now let's say that I want to drop a via but stay on the same layer. Okay, in that case, I hit the spacebar. And then if I hold down Shift and left click, I will place a via and then continue on the same layer. In older versions of EAGLE, you just had to do a Shift and left click to place the via. In this one, you have the necessity to place the via by hitting spacebar or using the middle mouse click, and then holding down Shift left click to stay on the same layer. Now, the reason we do this is in preparation for future routing enhancements like push and shove. You want the routing engine to be able to take the via into account. Under our old setup, where EAGLE would place a via after the fact, that just wasn't going to fly. So by having it work this way, we can now anticipate the new routing features for push and shove routing, etc. Okay, again, I can click my scroll wheel, select to route 15. You'll notice it'll stay floating on the mouse cursor. I left click, and I can finish at the trace there. Okay, so let's go ahead and rip up. If there's any questions, guys, put them in through the chat. I believe Ed is answering them.
Yeah, I'll take care of them. I've been taking care of them.
Okay, cool. Okay, so one other thing I wanted to show you guys here with the routing. Let's go ahead and start using some of the new features that came in. So I'm going to click on the route command. Let me switch to some other layer. Switch to top. Okay, and I'm going to go ahead and finish this one. Now I'm going to turn on loop removal. Okay, what does loop removal do? Well, loop removal makes it very easy to rework a trace. So let's say, for example, I determine that that's not going to work later on. What I can do is I can immediately left click on the existing trace and go off in another direction. Okay, let's say I decide that I want to come a little bit tighter around here. That way I buy myself some extra space. The second I left click now, you'll notice that that extra loop is completely removed. So it makes it really easy to rework your traces. Okay, in fact, you can do that at any point. And I can do something like that, and it really simplifies cleaning things up. So that's the essence of what loop removal is. Now, loop removal is going to have certain situations where it won't undo or it won't remove a loop. So for example, if you have a T junction where you have three traces crossing at each other, at that point the loop becomes ambiguous, so it won't automatically remove it. So let's say, for example, let me turn it off to create this issue. So I have something like that. Okay, where I have that situation of the T. If I turn it back on and I do something like this, whoa, wrong one. I do something like this, it won't automatically remove the loops because now there is three wires at that point and it's not clear which needs to be removed. But usually you're not going to do funky shapes like this, so it's kind of just a theoretical exercise to show where the tool isn't going to help you, but most of the time it is going to help you because you're maintaining rational loops. You know, you're doing rational traces. So let me go ahead and clean this one up. And let's go ahead now and just route a few traces. That way we have something for the obstacle avoidance to kind of walk around. So I'll route this one. It's probably going to be a little close. Okay. Sorry. Okay, over here. Okay, and where does this one go? Okay, we'll start doing the walk around with this one. So the way the walk around works is it's not gonna hug the traces. So like right here, I'm gonna start this trace. I have full manual control over it. Okay, I can do all sorts of craziness. I can do whatever I want at this point. It will only jump in if now I start to violate, or if I try to violate. At that point, you'll notice that it's going to limit where I can move and what it's going to do. Okay, it's trying to walk around all the obstacles to get from point A to point B. So once I click at a point, now it maintains that. So I can keep going down. If I try to run through anything, you'll notice it's walking around it. You can start to get some very interesting little things going on when you do that. And it'll actually try to find all sorts of ways to get there. But again, once I left click, I'm keeping a portion of it. I can keep going and going, and you can see it's really avoiding everything. I literally cannot route through an obstacle. It's going to walk around. So I keep going, and there. Now what it's doing this whole time is it respects the clearances. So it's respecting what we set up in the DRC. You don't have to worry about these creating issues when you run the DRC. Okay? And let's even observe that with the thick traces of the power nets. So if we go over here, notice we have a really nice big trace. Go ahead and take it to there. Take it to there. Okay? If I now go through here, obviously I can run into it. I can go past it and do a loop removal. Although probably here it won't loop remove. It'll just kind of short itself out. Okay, let me find another. I know what I'm going to do to test this. Okay, so we have these, and now here we have another power trace, okay? And notice that it's trying to maintain the larger clearance that I specified for the power traces. It's no longer keeping the 10 mil. It's actually doing a little bit more. And we can really show that off if we go to our net classes and set something ridiculous here. Let me pick 30. Okay. If I now route this guy, you're going to see it's really spacing away compared to before. Whereas before we had it kind of like halfway through here, now it's really keeping that distance. So when you're using the walkaround mode, you don't have to worry about DRC violations. It's going to respect your net classes, and if those aren't set up, then it's going to respect whatever you've defined in the DRC. Okay, so that's the essence of manual routing using these new tools. Now what you want to leverage for now a few general points about routing in general. Always keep shortest paths as best as you can. The shorter a trace is, the less likely it can behave as a transmission line or as an antenna. So rule of thumb number 1, keep everything short. As short as you can keep it, the better off you'll be. Number 2, whenever dealing with signals that could couple, like that are noise sensitive, the minimum separation you want to have between them is twice their thickness. Okay? So whatever the width of the trace is, of the two traces are, minimum separation you want between them is twice their thickness, if they are sensitive traces. Now, you have to make the distinction of what is sensitive. Okay, it could be a low-level analog signal coming off of an EKG sensor, for example. It could be traces that can easily serve as antennas, like if they're long, if you have a lot of long traces. All of those are at risk for becoming an antenna of either receiving or radiating noise. So you have to make those determinations based on what your clock frequencies are in your circuit, what your levels are. You know, a large signal that swings a few volts is much less likely to be corrupted by noise than a millivolt signal. So you have to make those determinations in your design and route appropriately. Do you have a component that's going to dissipate a lot of heat? You have to take that into account to avoid maybe nearby caps, having their lifespan shortened or affecting their performance. There are many components that are very sensitive to heat, so you have to keep that in mind. So shortest traces, keep the trace as short as possible. If you have anything where you're afraid of noise coupling, at a minimum you need to maintain twice the width clearance for them. You also want to make liberal use of planes for your power rail and for your ground signal. A plane serves as a low impedance path back to the source. So that's going to minimize ground loops. It can also minimize radiated noise. So if your board can have it, make sure to put in power planes. And finally, you want to always analyze your high-speed signals. And the high-speed aspect is determined by what is the fastest edge on your board. So don't look at just frequency. Don't look at a basic, if you have a 10 hertz square wave and you're like, oh, that's fine. It's super slow. It should be. Look at how quickly that square wave transitions. If you're talking of a few nanoseconds, that's a high-speed signal. And now you have to start treating it as a transmission line and taking into account transmission line theory, electromagnetics. So those are some of the main factors you want to have involved. We could definitely talk about this for hours, but we've reached the end of the webinar now, so I'm going to go ahead and kick it back to Ed. We can do a Q&A section, and Ed will also be reviewing what we've covered in this webinar.
Excellent. Thank you, Jorge. Well, we have only one question that I received on a personal note was in regards of differential pair routing. So the differential pair routing, does it take into account the obstacle routing and DRC and things like that? I got that as a direct message.
So currently, the walkaround does not take into account the differential pair routing. It does not. So when you're running meanders and things like that, right now it's not incorporated into that walkaround mode.
Okay, very well. Okay, is there any other questions that anybody would like to post while we're still here? Okay, you could always reach us at support at it's Eagle support at Autodesk.com. That's eagle.support@autodesk.com. That's our email address. And just to do a slight recap of what we have covered here. So one of the reasons we went over DRC is that really DRC really dictates your preferences on the board or the preferences of the board house you wish to use. So we went over your layer stack up, if you're going to have blind vias or buried vias as well. What clearances mainly used? Now remember that the clearances that Eagle have by default are very generous. So if you're going to be using a lot of SMD technology, it's quite possible that these are values that you may want to change. Also on the distance tab, we were talking a little bit about the distances from the board outline. This is a very generous default value as well, which is set up entirely at 40 mils at this time, but this is something that you could actually change. And the drill hole size mainly is pertaining to regards to the hole size of the vias you're going to use. Got your sizes tab as well. And we went over about what net classes do and how does it reflect on the manual routing as well. And just in case you didn't know this, but if you were using the auto router, the values set on the net class will override the values on the outer router as well. Now when we came to manual routing, we did some basic routing, but then again we introduced loop routing, which gives you the capability of having a looping routing, or you could have loop routing removal as well. And the walkaround routing, also referred to obstacle routing, was also demonstrated here as well. Thank you greatly for joining us, Jorge. As always, thanks for the information. If you have any questions, please shoot us an email. And thank you for attending, and register for the other classes that are coming up later this month. We're going to be talking with a pro in regards of you're done with your circuit board. Now what's the next step to do? Okay, we'll be getting some tips and tricks and techniques what you need to do on the board. That way you can go ahead and take care of this. Okay, thank you very much and have a great day. Bye.